Hi again. So previous tutorials have talked about loading files and how we can, what the different areas on the CPC Snooper Analysis tool shows you. So I'm just going to load a file quickly again, and we're going to look at a specific train and follow it through on the Snooper Analysis tool, so we can see what features are available to view the behaviour of the train on the railway. So I'm going to look at a specific train which consisted of VABCs 66 and 87, and show you how we can filter on command and response telegrams by that train. Now we can look at what that train is doing on the railway. So first of all, I'm going to start off by clearing my current command and response filter, and then I'm going to right click on my vehicle ID and left click in this box here, and then enter the numbers 66, then left click on add, left click in the box again, 87, then left click on add, and it's added it to our vehicle filter. Now I can click on this filter active button at the top here. I can click on single step. Now we can see that we're only looking at command and response telegrams from VABCs 87 and 66 here. And now we've gone through a few telegrams, the tool is telling us some information about this train. So we've got the slave on the front, master on the rear, it's going in the upward direction, its correlation, and its physical position on the railway as well. So 66, here you can see that this is the passive VABC. I'll step through 87, you can see that that is the active one. Now move this window out of the way, there's a range of information I can see for this train. So we'll look at the VABC real-time graphs to start off with. So click on displays and then left click on graphs, and it will load me up a number of different graphs at once. So I can have up to about 4 of those open and look at different VABCs. The top one I'm going to look at 66, right into this box, enter, and then the bottom one I'm going to look at 87. Now I showed you how to use the auto step function previously to step through multiple telegrams at once as opposed to just single telegrams. So we're just going to slow it down slightly by increasing this number here. Click on auto step, and on the left here we can see that it starting to plot information from the command and response telegrams onto these windows. Now there's a few things to note here. One, 87 graph is updating much more frequently than the 66 graph. Now this is to do with the command and response poll rate of active and passive VABCs. So active VABCs are polled much more frequently than passive ones, so we only get about 1 in 5 or 6 telegrams, 66 telegrams compared to the 87 VABC. So we get about 6 times more of these as this is active. This changes as trains are approaching platforms and for other different reasons, but we're not going to go into that here. But you can see here that information is being plotted onto the graphs. The yellow here, background, tells us that this is the currently passive, this VABC, and the fact that this is clear, background, this tells us that this is the active VABC. We can hover over here and bring up the key, which tells us things like, up at the top there, the background, VABC, active, passive, and what all the other displays mean. But I'm going to talk you through most of those anyway at this point. So, but it's good to remember that this here is good for reference. So, the blue at the top here indicates ATO. If you've looked at the SMC view before, the blue is always ATO, yellow is PM, orange is RM. So these correspond to the train mode numbers. Here, this green line is the vehicle's actual velocity. So you can see that the train is increasing in velocity here. And then the red line here is the maximum target speed. The pink line or magenta line here is the distance to go. So we'll see that decreasing as it pulls into a station. And this line here is the door enable. So we'll carry on single stepping, and I can talk you through the station stop. So at this point here, we can see that there's some interference on the comms. So if we look here at the key again, in the banner, the cyan, which we've seen a new the cyan up here, which we see quite a few of, and the red, we see those in the vertical bars in the banner at the top here. So this is a loop change. So we get a few no responses from various loops as it crosses the loop, and then a few drop telegrams also when it crosses over the loop. If we see lots of red bars in vertical bars in here, as the train is driving around in general, it indicates that the train has poor comms and needs to be pulled in for maintenance. So at this point here, our movement authority is dropping off on the train, so we can see that the speed's starting to reduce. So as we run out of movement authority, the train should come to a stop. You can see at this point that as I'm auto-stepping, the pole frequency on the passive VBC has increased in time to be in time with the active VABC. So the pole frequency on this one's increased as we're approaching the station stop. And here we can see the train stopped and the doors have been enabled. You can see a few more things in the top banner. We can see the type 1 responses, which are these green bars here, just after the train has stopped. So this will be the train reporting its docking status and the target point deviation. Yeah, and this here I said was the door enable status. It's actually the door status of the train. So doors open, doors closed. Continue stepping. We can see here we're at Bermondsey 1. So this is the loop location. So we're at the Bermondsey platform 1 at this point. Doors have been closed and the train starts pulling away.